Hi friends, this is Anil here. Welcome to my YouTube channel Shreyas Data Insights. So before going to the actual, let me explain few things. So coming to my introduction, I'm a Cloud Data Certified Hadoop professional, and for the last 6 years I'll be providing corporate as well as online trainings. Of course, apart from Hadoop, I'm good in Spark with Scala, ELK, Cassandra, MongoDB, and of course Hadoop Stack, right? And coming to this training mode, how I going to provide the sessions here. So as I mentioned, this is not the live sessions, it's kind of a offline. So continuously the sessions will be recorded and those will be uploaded to YouTube, and the link will be shared of course to the subscribers, and you can share to your friends also who are interested in this big data Hadoop, and they want to get in touch with this particular Hadoop. They can learn Hadoop. Of course, as I mentioned, training cost is absolutely free here. Okay, so you're not paying any amount or training fees kind of things to me here, so you're getting a benefit, right? So why I'm doing this, why free? Well, first of all, that's a question, right? Because it's a Hadoop is having a very demand still, even apart from my commercial activities and all, right? Why I'm providing this free? Because we know the crisis outside, what happening outside, right? So I would like to just help the OPT candidates in US, and of course the working professionals who just like they want to change their career right into this big data Hadoop, and they want to choose their career as Hadoop professional, right? So to aiming at those particular people, just I'm providing these videos in YouTube. Okay, at the same time I'll really requesting the guys who are not interested and the time pass candidates who are, maybe I'm not criticizing anyone, but of course even then please don't follow my YouTube channel, or please waste your time as well as my time as well. Okay, and what are you going to learn in these sessions? So of course I'll be providing introduction to big data initially, then followed by we'll be discussing about Hadoop ecosystem. We'll understand how Hadoop really answers the big data problem, and after that we'll be understanding generation 1 and 2 architecture, right? Then I will be showing basic hands-on, okay, which will be really useful for you in real time. Then we'll start with the Pig, Hive, HBase, Woozy, Flume, and Scoop, of course. So this is the Hadoop ecosystem components. So apart from the MapReduce, I'll be covering all the Hadoop ecosystem components here. If really you people are showing interest on that, okay, I'll be adding the MapReduce also later. It's not a big deal. So how are you going to learn this? So just you need to subscribe to my YouTube channel, and you need just to follow, okay, so that you are not at all missing any sessions, and you are having plenty of time right with you, so that you can do the hands-on part also once I started. Okay, so of course what are you going to get from my end? So session videos I'll be posting on my YouTube channel, and of course I'll be giving a link or to a dedicated drive I'll be providing, where I'm going to keep the data sets and the virtual machine also. If you're really interested, you can download the virtual machine from your end and you can do the practice. So if you're having any doubt, you can just send me a mail, or in the comment you can comment a particular doubt also. It's not a problem, and we'll plan this also, not a problem. So 5 p.m. IST or 6:30 a.m. CST Sunday. So we'll plan some live sessions also in our coming sessions. Suppose you're stuck somewhere and really you would like to interact with me, send me an email, come with your doubt and get clarified. This is how we're going to go through these sessions. So when you're going to get these things? So from 24th of April. So like this, whenever I'm getting some time, okay, I'll be recording sessions and I'll be sharing to you. Okay, so but what you need to do is just you need to subscribe my YouTube channel and follow and get the benefit from this channel. Okay, all the best to you people. Hopefully you'll be enjoying the sessions from my end, right? Now coming to this big data analytics with Hadoop. So we're going to see some introduction now. So coming to this is the ecosystem. So Hadoop is not a single component, first of all. Okay, so Hadoop provides storage as well as processing as well, and it's added with some other stacks also. And every stack, for example, this Pig, Hive, Scoop, Flume or HBase, Woozy, and of course next generation Hadoop are yet another resource yet another resource negotiator, resource management. So we are having a separate stacks, okay, because Hadoop is not a single component. So of course slowly we're going to adapt the things here. What do you mean by storage and what do you mean by processing? What do you mean by HDFS? Because these names, like, you know, these are pretty much new, I guess. The guys who are not, you know, having a basic knowledge in this Hadoop, or who didn't, you know, done any R&D. Okay, because already some guys are there, so already having some knowledge, right? What do you mean by big data, and what is a Hadoop stack, and what for big, what for high. But my intention is, in the demo itself or a first session itself, I don't want to confuse you. Slowly we'll understand what you mean by big data first of all, followed by how Hadoop answers the big data related problems here, then the other stacks like Pig, Hive, HBase, why for those particular tools, what they're really going to do in real time. So we'll be understanding that. Fine. Right, so coming to this prerequisites and system requirements. Suppose you want to learn and you want to go right with this Hadoop area, you should be good in object-oriented programming. Okay, why? Because here we are having a concept called MapReduce. So MapReduce is a programming or processing, I mean to say, how you're going to do in Hadoop. So we are having, you know, mapper, reducer, a lot of other stuff, of course. Apart from that, we'll be following some related concepts with object-oriented programming. So if you're having any knowledge, any prior knowledge in Java, it's really added advantage for you. Okay, right. So coming to this knowledge in Unix, why you should have knowledge in Unix means in real time you are going to connect the Hadoop cluster and you are maintaining everything using commands only, right? So that's the reason if you're having any prior knowledge in Unix or a basic knowledge in Unix, it really helps you, because you are not finding any graphical user interface kind of thing here. At the same time, when you're talking about data analytics, better to have some basic knowledge of SQL as well. Okay, nothing but structured query language. So if you're not you know, good in these areas, not a problem. What you need to do is try to get some basic idea. Okay, before learning MapReduce, just quickly review this object-oriented programming concepts before starting the hands-on part. So please review or recap your Unix basic things, right? And even though you are not working on these areas like Unix or SQL, you are not working even then, you know, somewhere we might study, right, in our graduation, in our MS, or, you know, post graduation, whatever it may be. So just quickly recap the things, that's it. Okay, no need to we should masters in these areas, but at least quickly recap. Okay, at the same time, before working with a Pig and Hive, better to recap your SQL thing. So it really helps. Okay, right? And coming to the installation, if you want to install Hadoop on your local system, okay, so Windows, if you're operating any Windows operating system, we don't have any strengths of it, of course. Now if you Google, you know, how to install Hadoop on Windows, you'll be getting a lot of videos, but really it's not recommended. In real time you never get a Windows machine for Hadoop. Okay, so either you're getting a CentOS or Ubuntu or any other like Red Hat Linux. So probably you'll be getting a Unix platform, that's it. So on top of that only the Hadoop libraries will be installed and you're going to work on. Okay, so if you're already having a Windows machine, so no need to format or no need to erase the existing operating system. So only thing is you need to take the help of any virtual machine like VMware Player or Studio or Oracle VM VirtualBox. Any VM player you can take, and on top of that you need to install CentOS or Ubuntu or Red Hat Linux, and on top of that of course you should install the Hadoop libraries. This is one way if you want to maintain your cluster locally, or if you want to maintain your machine. Because I'm not saying cluster by, because you can go with a single node or a multi-node locally, as well as you can go with a cloud level also, like you're having a GCP, AWS. So in this AWS and or Google Cloud Platform, nothing but GCP, there also you can build your Hadoop cluster. It's a very simple procedure. Okay, but you won't get any internal knowledge. I mean to say, you don't get any configuration parameters level knowledge, but a kind of ad hoc machine kind of thing. So if just you're giving how many nodes you're looking, what is the configuration that you're looking, so if you're inputting these fields and having an account with AWS or GCP, that's more than enough. You can build your Hadoop cluster just within 10 to 20 minutes. Okay, so you can practice there also, it's not a problem, but initially better to go with a local system. So once you're good in that, you can work with any cloud based systems also. So because once you're working with any cloud based, and so you need to configure PuTTY or VT kind of thing, so that you can connect the Hadoop cluster from GCP to or AWS via this PuTTY or PuTTY. Okay, so a lot of procedures will involve, so you should have some good idea on this. Okay, RSA and of course this particular other configuration related settings. Okay, so right, so this is what I mentioned here is a local system configuration. So if you're already running with a 7, 8 or 10, so what you need to do, just you need to install a virtual machine, on top of that CentOS, and on top of that you need to install the Hadoop libraries, right? Of course later ones, like the guys who are interested and who are really following my sessions and they subscribe to my channel, I'll be providing a virtual machine and I'll be providing a link also, and you can download and you can start hands-on. Because the guys who are not having any knowledge, installations and all, please don't waste your time. In real time, as a Hadoop developer, it's really a black box for you. Okay, for small scale companies, maybe you'll be involving with the Hadoop admin people, but most of the time developer is not at all involving any admin activities. Sometimes you get some flyers like we be giving a training on Hadoop admin as well as developer. So what kind of admin activities that they really providing? Installing Hadoop, installing Hive, installing Pig. Guys, please don't get confused with that. Hadoop administrator responsibilities are not only limited to only installations. Okay, they're doing a lot of things: version upgrades, applying patches, okay, maintaining the cluster in a healthy manner. So a lot of things will be involved. Okay, don't get confused with those flyers. Okay, right. Anyway, these are the requirements for working with Hadoop. Now coming to this training content, what you're going to learn. So you're going to learn initially introduction to big data followed by Hadoop. Of course initially I'm not adding this module. After that we'll be working with Pig, Hive, HBase, right, Lumen, Scoop, Uzi, and I'll be explaining a real-time flow also, how it happens in real time. Okay, from where you get data, where you will store the data, and how you're going to process the data. That's the main thing, right? So once you're familiar with these things, happily you can work. There's no problem at all. That's fine. Now coming to this, of course this is a regular thing, right? I'll be providing some slides for my regular online trainings, so some may be related to you and some may be irrelevant to you. Of course these sessions, of course, a kind of combination with the concept and hands-on. So if you're really interested, just ping me. I'll be providing ebooks, okay, and we'll be discussing some real-time use cases also, and as I discussed, I'll be providing a pre-configured virtual machine also. And one more thing, one suggestion I can give you, please don't open any books, because we are having a lot of books. If you Google, okay, on Hadoop, a lot of books and a lot of others, right? And even videos also, right? A lot of Hadoop videos you'll be getting. Some of them are free, some of them are, you know, or premium, and kind of like you're I mean to say you're purchasing the courses, right? So a lot of things and a lot of videos and a lot of other stuff really. But the thing is, first of all, completely follow from a single source. So once you understood with that, right, then you just open any other ebooks to get more knowledge. Okay, see, if for example a trainer is giving a training, so it purely depends on his, you know, ability, how many scenarios he faced really in real time, what is the knowledge he is having in terms of sorry, in terms of conceptually, and of course practically, what kind of real-time scenarios he faced and what are the challenges he faced. So all this come into the picture. Okay, so while giving the training, so hopefully you'll be getting a lot of benefit from my end. Okay, right, we'll see. So this is our agenda. We'll see, try to give some introduction to big data. So the guys already having some idea in this big data. Okay, that's kind of a recap session for you, not a problem. So look at this. I'm showing some Samsung mobile here, and please don't mistake me here, like I'm not any sponsor, I'm not promoting a Samsung mobile here. But why I have shown you here is, look at the configuration or the specifications. So it just supports micro SD up to 64 GB and internal 4 GB, and of course RAM is having 512, and this is about the CPU and the speed. So this is like, you know, just initially we just purchased a smartphone for our, you know, regular day-to-day activities. So do you think this phone really makes you happy for all the time? Please understand here, I'm saying always, not a particular period here. So this may not. Why it's not? Why it's mean, you know, all the time? Because maybe we are not happy with this configuration or the specification. So just RAM with a 4 GB, sorry, internal storage is only with a 4 GB, RAM is with a 512 MB, and CPU just a dual core. So that's the reason, like, you know, we're just changing our smartphone. Now okay, this phone is good enough to have a micro SD up to 200 GB and internal 16 GB and RAM 2 GB for CPU quad core. So we're expecting, our expectations are somewhat, not all, of course somewhat, is going to fulfill here. Now do you think this is the you know, lifetime solution for us? Obviously not. No, right? Why? Because even this particular specifications also makes you happy for some time, only for some time, not all the time, right? So again, we'll be changing our smartphone now. Very good thing, right? It supports micro SD up to 512 GB, and this is the internal, this is the RAM and CPU, and very good configuration we are having. Lot of connectivity, everything. So why you are changing the phone here? That is the first question. Just because of, like, you know, the model or the, of course I'm not taking other specifications because those are not relevant to us for this discussion, like camera or, you know, audio and other things, other HD. So I'm not taking any other specifications. So my interest limits to the storage, processing, and the RAM here, how fast it can process the data, and what is the CPU. So coming to this, why you are changing our smartphones like this, right? Just think a moment here. So whenever you're looking for more storage and, you know, more processing, nothing but you just like would like to open multiple apps at a time, and you want to have a good internet connectivity on your phone, right? So those are the reasons really influences you to change the smartphone. Okay, so that's the reason you just keep on changing and you are looking for some gadgets which are really qualifies to your requirements, right? So the main thing what we need to understand here is the data that we are receiving, right? Maybe you're taking some pictures, maybe you're receiving some WhatsApp messages, videos, through, and of course some audio recordings. So the way you're getting, right? So your data is not at all limited to a particular kind of boundary. Like you can't keep, okay, I'll be limited to only 1 GB data or 2 GB data, right? So you cannot even predict also how much data that you're going to receive per month, per year, or whatever it may be, right? That's the reason once our requirements are not met with the particular existing device, we are looking for a new thing in a similar fashion. Now understand the problem in the corporate sector. See, for example, you're having 5,000 employees in your organization, and just you would like to maintain those all 5,000 employee records in a table. The table size may be 10 MB or maximum of 15 MB, right? Not more than that. But if your enterprise is maintaining not a kind of a structured, they are maintaining some videos, they are maintaining some audio data, they are getting some sensor data like IoT sensor, they're sending some temperature, right? And maybe they're giving all the details also from the different sensors. You're getting some messages. So IoT sensors are sending a lot of information, humidity, rainfall, or kind of thing, this like the way GPRS signals. So a different kind of data is coming really, and they need obviously a lot of space here. So look at this simple thing here. So initially, like we just planned, okay, my enterprise may be maximum getting some 100 GB of data, right? So I'm receiving a data and I'm storing the data in my relational database server here. So once it reaching to the 100 GB, okay, so what next I have to do? So the existing system is really not at all fulfilling my requirements, as I'm looking for more storage, right? So that's the reason now just we plan for a terabyte. Okay, now the scaling is a terabytes here. Do you think this is an all-time solution? So once it reaches to 100 terabytes and your data is like growing like anything, and you are expecting petabytes of data now this time. So once again, now the existing system will not support that. Got that point here? So this is the main issues with the enterprise data, the way how we are feeling with our smartphone in terms of data, because we're getting a lot of videos or messages or contacts, whatever it may be. We're maintaining a lot of data in our smartphone nowadays, a lot of apps we are installing. So we are looking for good storage, good processing, right? In a similar fashion, enterprise level also, they will also have the same thing here. The existing systems may not support to the higher end, so keep on changing. Okay, keep on changing the servers is not a good idea. Okay, is not a good idea. So always, because we have to keep some metrics or some parameters, like we really would like to maintain a petabyte system, or I mean to say more than that, like the way, but even then we cannot predict completely, right? So this really gives a lot of problems here. So I said simply here I'm getting a lot of data, that's fine, but from where I'm getting all this data here? Look at this. So there's something like 2018 data just I'm showing. So this is what exactly happened for every minute. So LinkedIn is saying 120 plus provisions they gains here, and these many watches happened, videos have watched in YouTube, right? So in Skype, these many callers made some call, like the way Uber users take these many rides, right? So like the way these happens for every minute, right? So now all these guys has to maintain their data, right? They have to maintain the data maintaining in the sense storage and processing. So they had to do that, right? So look at this data, how much fastly that really hitting. So that's the main question here. So how to store and how to process the data. Storing doesn't give any sense, right, if you're not processing the data in a proper way. We have to process as well. Okay, so look at this. Google has conducted these many searches and Amazon shipped these many packages. So like the way for every minute these many transactions happen. Now we are in 2020, the list is very big, right? So this is the data explosion really. So that's the reason why the enterprise level, like they are not able to maintain with their existing system. Okay, they are not able to maintain the data with the existing systems. Okay, now we'll try to understand what do you mean by big data here and where it comes. So there is no standard definition for big data. There is no standard definition. So everyone based on their experience, how they receive the data and how they are storing and processing. So they will come with their own definitions. This definition is not the a kind of thing, but standard thing I mean to say. But even then, look at this. So big data is a term for data sets that are so large or complex that traditional data processing applications are inadequate. That's fine. So large means what here really? For example, I am receiving 10 MB data daily. 10 MB data daily. So throughout the month I'm getting 300 MB data, right? So my system can maintain only some 5 GB data, for example. So 300 will be added. So once it's reaching to the gigabytes level, it is a big data for me. And the other guy, maybe he's receiving 300 MB data per hour, not the day. I'm getting 300 MB data per month, and the other guy is receiving 300 MB data per hour. So now you can calculate how much data he's receiving, per month, right? So like the way, so whenever the way you are receiving the data and your existing system is not qualified to validate the data, then you can say I am receiving big data. That's it. So for me, maybe gigabytes itself a big data, and for you it's terabytes are the big data. Okay, there is no standard thing. So for my end, why I'm saying that's a big data, because my existing system is not able to store and process the data. That's the reason I'm saying I have received a big data, right? Got the idea here? So don't think that the guys who are receiving terabytes only a big data, and the guys who are receiving gigabytes is not at all a big data, right? It's not like that. And coming to the complex, so we are having generally the structured and unstructured and semi-structured data. 3 categorized data we are having. So 3 categorized data. So whenever your enterprise is receiving the structured data, there is no problem. There is no problem at all. They can maintain your data very easily. Like we are having good concepts like RDBMS. So you're having databases, tables. You can do the indexing here, and you can go with normalization. You can go with ACID principles. With a lot of things, right? You can maintain the data. So there is no issue with that. So whenever your enterprise is having or expecting or they're working with the structured data, absolutely they don't have any issue with the big data. Because starting off this session itself I explained. So 5000 employees data can fit into a 10 MB file. Then you cannot say, right, they're receiving the data in terms of terabytes or more than petabytes kind of thing here. And this is really easy to maintain. Even though you're having very big data, then it's really easy to maintain. But problem only comes with this semi-structured and unstructured. So coming to the unstructured data, you're receiving analog data or audio video streams, GPS tracking, right? So these are having a different format, so are not having any inherent structure. So this will not fit into a particular table. Like you cannot put the data into rows and columns kind of thing here. you cannot apply any ACID properties, or you cannot apply any other normalization principles. Like the way you're having a semi-structured data, like our email, XML, and other thing. So some fields, structured, and some of them are unstructured. Like for example, if you want to send an email, to is a structured one, right? You have to say anilkumar.triple@gmail.com. So this is the way you have to send a mail to me. In the subject line, you can write anything. There is no restriction on that. And coming to the body also, there is no compulsion. And you can attach any files, or audio file, or a text file, or a video file. So once again, it's unstructured. So a combination, right? Your email really matters here. So kind of a semi-structured thing here, right? So whenever your enterprise is expecting or having semi-structured and unstructured data, that's really creates a problem for them. So look at this second statement here. Every day we'll be creating 2,500 petabytes of data. In that, 90% of the data in the world today has been created in the last years itself alone. So this much data is created daily. Now the question, how to store and how to maintain this particular data here. That is the main problem here. Okay. Now coming to the dimensions. If you Google this, someone will say 3 V's concept, 4 V's concepts, and someone will say 5 V's concepts. So which is new and which is old here? So it's not like that. The way your enterprise treats the data only matters here. So what's the first factor here, or the first dimension? Volume, terabytes to exabytes or something. So here, coming to the volume scenario, you may receive megabytes and your ceiling factor is gigabytes. That's the reason you're claiming you will receive the big data here. Like the way the other guy, his system is only limited to a terabyte and he's trying to get more than that, so he can claim he's received the big data. So coming to the volume, okay, so there is no such a standard thing here. Only thing is you have to look for your existing system, whether the data is fit to that or not. If you're receiving more than that, you can claim you are receiving a big data. That's it. And coming to the velocity, the second factor here. So how fast the data is receiving for you really, that's a matter here. For example, take any call data records, right? How fast, like if you're making a call, 500 plus fields, call data records has to be maintained. How many seconds was the call duration, it really happened, and incoming number and incoming and the caller and the receiver, they have to maintain the details, under which tower they belongs to, let's say local call or ISD, or or a national level call or a roaming call, right? And whether it's a call is a within the sector or outside that, like idea to idea or idea to geo kind of thing. So a lot of things will be coming to the picture. Maybe you just to maintain just to have given a 5 to 10 seconds call, but it generates obviously more than 400 MB data here. So very fastly that data even also generated. Like take the stock market data, lot of transactions are happening, right? Per second number of transactions are happening. So we should be in a position to store and process the data here. Like the variety, structured, unstructured, and different data that you are receiving. Maybe you're receiving video streams, and maybe you are receiving some GPRS signals, or maybe you're receiving some other IoT signal data to find out the maximum and minimum temperature, and to get the rainfall, to get the humidity level, right? And finally veracity also. Sometimes data really confuses, so you're not getting the complete set of the data here. So always you'll be in a dilemma whether you have to trust the data or not. Okay, like I have given some data to you. For example, I have shared 100 student detail and asked you to find out who got the first rank among all these 100 students. So I had to provide all the 100 students serial number, name, and the subjects that they appeared, right? Then only you can come with that. For some of the students, I really missed out some marks. Then how you can claim a particular person secured first rank, right? So this is called a kind of a veracity we can call data in doubt. So we are not having full student details, right, to announce the first ranker here. Similarly, the final one is a value here. So how we can make the data into more productive? Okay, how we can get more bugs with the data existing? How you can process the data really into a meaningful, so that you can make more business. That comes under a value here. So these are the some dimensions, okay, you need to keep in mind when you're talking about any big data scenarios. Now coming to the technical challenges for the existing systems. First one is the scalable storage, and the second is a parallel processing, and of course system integration. That's the third thing. So we'll understand one by one here. What do you mean by scalable storage? So in the first example, like in a smartphone and the other example, we have noticed that. So every server having certain limit, certain capacity. If you're receiving more than that, they cannot accommodate that much data, right? So you have to keep the throughput also, and pipeline throughput also. How you can build the pipeline, because from different sources you are receiving the data, so you need to pipeline them to store in, because you're receiving the data from multiple sources. How you can build a pipeline with that, and how you can process the data very fastly. That's nothing but the throughput here, right? And how much you can provide a space for storage also here. And coming to the next thing, parallel processing. What do you mean by parallel processing, first of all? So this is very simple discussion that I can say, like a divide and conquer method. If you want to say in a technical word, a distributed computing. That's it. So instead of processing your data in a single machine, if you're distributing the data to multiple machines, it's really easy for processing. Look at this slide. So I had to read 10 terabytes of data, and just I'm having one machine, and here on the other end I'm having 10 machines. So this is the capacity of this machine, and this is the capacity of these machines. Now, for example, to read this 10 terabytes of data, this single machine is taking 45 minutes. Obviously, these 10 machines can complete the task in just in 4.5 minutes. So what do you mean by this really? So this is a concept of distributed systems. Nothing but we are trying to process the data parallelly. We are distributing the data initially, and after that we'll be processing the data here. And next thing is system integration, because we are all not working on a single technology or framework kind of thing, right? Maybe someone is working on SAP, someone is working on any RDBMS, someone is working on any business intelligence systems. So our proposed system should have some good integration with newly systems, like Hadoop has to be maintained or has to be designed. It should provide not only Hadoop, any new system should have such a feature of the integration, so that we can build a pipeline. If you are not providing any system integration concepts, it's really tough job, right, to bring the pipeline or to process the data. Kind of a ready to use tools here, I can say. So these are the some technical challenges for the enterprises. So already we have seen this, so I'm skipping the slides here. So now coming to the limitations of traditional RDBMS systems. So whenever you're looking for storage and processing of images and video, nothing but unstructured data, it's really tough job. Like the way if you're having any files, very large files like Excel files or PDFs or CSV, JSON or XML, and sensor data, and maybe you're looking for some ad hoc and exploratory analytics, nothing but immediately you're trying to process the data for a meaningful thing here. I like the way you like to integrate the different systems and doing ETL jobs here, nothing but cleanup jobs. And maybe you're looking for some machine learning. So these are all not going to fit with your traditional RDBMS systems. They're good in, of course, they're good in whenever you're having a structured data, they're really good in storing and processing. But apart from that, once you're receiving, I mean to say your enterprise is receiving other than the structured data, like a semi-structured or a I mean to say is complete unstructured data, that time they will have limitations only. right? So find from where you're getting the big data here, like more data, variety of data for storing and processing, like market analysis, consumer behavior, social network and sentiment analysis, a kind of recommendation systems. So earlier, coming to the recommendation systems, is kind of a hard coding they used to do. Okay, now like based on the consumer, how the consumer is purchasing the products, how is really showing interest on the different products. So based on that, they're giving some recommendations. Okay, like there's a quite practice, right? If you're trying to purchase using any e-commerce platform like Amazon or Flipkart or eBay, whatever it may be. So whenever you are adding some things to your cart, you'll be getting some recommendations. The guys who bought this product also shown interest on this, also want to add to this product to cart, getting something, right? So a lot of machine learning algorithms are running in the background. So based on the data, they're giving some hint to you. So earlier just they are hard coded, now they are not hard coding. So based on the transactions made by a customer, okay, they will be analyzed and they're giving some hint, like social network and sentiment analysis. So you can in Facebook, and it's a common thing, right? So I'm raising a question and I'm trying to take the analysis, like how the countries are fighting against COVID-19 here. So I just would like to take some analysis on this, right? So based on that, how really, for example, talking about the America, so Donald Trump, how is really taking this issue? Okay, can he solve or not this issue? What about the world? Like you can take a lot of sentiment analysis things in this, like the way fraud and crime detection, supply chain mechanism, healthcare delivery and insurance kind of thing here, cyber security, finance. So these are the some areas, okay, where you can get more and more big data. Okay, so what are the issues with the traditional large scale computation? So earlier, whenever you're getting more and more data, just we are increasing the processor and RAM, that's it, because we are not having any concept called distributed computing. For example, earlier we used to have P1 systems, Pentium 1, with a RAM of something like 54 MB or 128 MB, very less configuration, right? So then we started evaluation P2, P3, P5, and after that dual core, core to duo, and i3, i5, i7, i9, of course. Now you and your personal laptop can have 64 GB RAM or 128 GB RAM also. That's not a problem here, right? But like the way what you're doing really. So whenever you're looking for more data and processing, just we're increasing the existing thing, right? Of course, we'll discuss that also technically, because I don't want to give more and more technical names in this session. Horizontal scaling and vertical scaling, we'll discuss that later, but understand the concept here, how you're going to process. So earlier this is the what exactly the things what you're going to do, just a kind of a supercomputer. So where we are putting more processing power, more RAM, to get more fast to process our data here. Because why you are having more trust on the traditional systems like supercomputers of thing means, initially we just have some issues with the distributed systems. Like first of all, it's really tough job to synchronize, because our data are now distributed to multiple nodes. Okay, take IRCTC. So they're having multiple nodes or multiple machines, right, or multiple servers. So like north, east, west and south, for example, they're having 4 servers. So all these 4 servers has to be in sync. Means what? So all these 4 servers should have the equal or same data here. So for example, I'm trying to get the train list from Hyderabad to Bangalore. Whenever I'm connecting to a north or east or west or south, I don't know, right? As an end user, I don't have any idea to which server I'm going to connect and which server is resolve my issue here, answer my query here. But all the servers has to give the same information, like any server, like these are the availability of trains and these are the availability of berth in each train. That's it. So they should be in sync, right? That's a really tough job initially. like partial failures. So suppose I distributed my data to north, east, west, and so that's fine. Something went wrong with my northern system, so it should not influence the remaining. So east and west and south system has to work as usual. This is called the partial failure, because I just have some issues with the north server, right? So it should not give any impact on the other working nodes or other working servers here. That's one more important factor we have to keep in mind, because these are some issues they identified. If you want like a particular enterprise want to move the things from the existing to the distributed environment, like they look for some SAN here, storage. At the same time, one more important thing here, compute time. Data has to copy it to the compute nodes. What do you mean by that really? So we are having two phenomena here, data to code and code to data here. Okay, data to code and code to data. So what do you mean by data to code and code to data? See, for example, okay, I'll be showing that in my next session. In Hadoop I'll be showing, because in the Hadoop also we'll be getting the same concept, so that time I will be showing that with a simple example, so that you can understand what you mean by data to code and code to data here. Okay, so whenever you're having a small amount of data, okay, so data to code is a good thing. Okay, I'm repeating once again. So whenever you're having a small amount of data like 1 KB, 10 MB, like the small files, for a particular query purpose, it's a really good thing, sending the data from one end to the other server. But you are having a huge data, terabytes of data, gigabytes of data, or petabytes of data, so it's not a good practice. So I'll be explaining the same scenario in our next session, where I'm talking about Hadoop. In that I'll be explaining. Please watch that session also, so that you get some idea on that. At the same time, so this type of storage is only good for relatively small amounts of data, but as you are having more and more data, this phenomena will never work properly. So that's the reason when you're planning a new approach, you have to keep in mind how to support the partial failure. Something went wrong with a particular node, how to secure our data. Okay, so how to rejoin a particular failure node without restarting full server, right? So all these things, like the way how to increase the proportional increase in the load capacity, because simply you're increasing the storage level, that's fine, but how about processing? So I have to keep in mind, right, about the processing also, because simply storing doesn't matter or doesn't give any sense. So you have to go with the storage as well as processing also. So you need to keep your mind, like proportionality also, right? Now proposed systems, how we are expecting that they can store any kind of data. Like for example, your RDBMS is saying I'm comfortable with only structured data, but what about other data, right? So that's the reason they should store any data, means it may be a structured or unstructured or semi-structured, and they should never claim that I only do SQL queries. So they should be good in machine learning or image processing or log analytics or anything, SQL queries or anything. So it should never restrict you a particular analysis, and they should provide some good speed also. Suppose you are running a query today and it's giving result in next month or next year, is not a good thing, right? So that data has to be distributed and has to be processed in parallel. Now you have to get the result very quickly here. Now I'm not taking these names here because this will confuse you. So we'll give the introduction to Hive and MapReduce, and the other stuff I'll be giving the clear idea on that. And come to the scaling. So there is no higher bound. Maybe today your expectation is only you're receiving gigabytes of data for this month or for this year. That's fine. The other year, the next year, maybe you're receiving terabytes of data or petabytes. So you should be in a position to expand your cluster size without changing or without buying a new thing. Got it? Right. So these are the some things we have to keep in mind whenever you're looking for so many proposed big data systems here. Right. So that's all from my end for this session, and in my coming session we'll be talking about Hadoop. So what exactly Hadoop really? Of course this is not related with you, this is my regular thing, online trainings and all. Now coming to this Hadoop, we'll be discussing about what is a Hadoop, and how it really fits for the big data scenarios, how it solves the big data problems, what is the advantage of Hadoop, okay, what's the basic terminology of Hadoop. So we'll be focusing on that. Okay, right. So that's all from my end. Thank you guys. So please watch these videos completely, right, and get more knowledge on this, and I'm happy to answer your queries. It's not a problem. So just send me. Anyway, you're having my email ID, right? You can send your queries. Please follow the sessions. I'll be providing a lot of interesting stuff in my coming sessions, right? So what you need to do is you need to just go through my videos and get subscribe to get more and more new things from my end. That's all. See you in our next session. Thank you.